Okay, so in this next talk, we're going to talk about DevOps in Azure for web devs. So there's this idea of basically running your websites, your web applications in the cloud on Azure, and some of the tips and tricks that are involved in that. We're not really going to look at much code in this talk. It's more about actually using Azure and some of the features in Azure that you can really take advantage of. So I'll take you back to my early days, my when I started my career. This is me as a 19-year-old, very smart 19-year-old too. And I used to be a server guy. So before I got into the world of development, I used to look after servers. I worked for a company in Coventry, and I used to maintain their server infrastructure. I used to be the IT guy. And this is probably the last time you'll see me wearing a shirt and tie as well. But even at that tender age, I kind of realised that actually looking after a server and sort of upgrading it and patching it and looking after network cable and things wasn't really where I wanted to be and wasn't really what I wanted to do. So even at that age, I started to move towards software development. And now here I am, I'm a web developer working for one of the biggest software companies in the world, which is nice. Another story is, this is my wife runs an e-commerce business. And this is her IT equipment. The whole thing, she runs the whole thing from this phone. So she gets her email on here through Office 365. She has all of her apps for managing Facebook and eBay and all those kinds of things on here. She uses Wunderlist. She uses Office on here as well for writing documents and spreadsheets and things. She doesn't actually have a PC. She just does the whole thing. And the only reason she can do this from such a small device is because everything's in the cloud. She doesn't have a server. If she had to maintain servers, that would probably kill the business straight away. She runs everything out of Azure and Office 365 and the other cloud services of people like Google and Facebook. And so this is really what the cloud allows. It allows us to have this huge levels of data available to us without any of the server infrastructure that might have traditionally been associated with that. So in this talk, we're going to cover a few things. We're going to look at specifically deployment in Azure. How do you get things into Azure in the first place, and how do you update things in Azure? We're going to look at scale. How does Azure scale, both out of the box, and what are some of the things you can do to have it scale intelligently? And then we look at using Azure for storage and some of the tips and tricks associated with using Azure for all of your static files. So Azure has a thing called an Azure App Service. It broadly has four things that it does. Web apps, which is what hosts web applications and web APIs. So it gives you a URL that you go to in a browser. This is more than just hosting though. This isn't just a case of kind of chuck your website on there and forget about it. There's a load of value added features. And this is the area we're going to spend most of the time looking at during this talk. We have mobile apps, which is really a back-end in the box for mobile apps across all of the different platforms. So if you're writing a mobile app across iOS, Android, Windows, that kind of thing, and you need a back-end, this is a great service. It kind of takes away all of the pain of designing your API and your database, and it does things like push notifications, offline sync, all that kind of stuff. And then we've got logic apps and API apps, and these kind of work in tandem. An API app is basically a wrapper for an API, and there's a load of APIs in the marketplace. So companies like Twitter, like OneDrive, Dropbox, Office, these all have APIs in the marketplace as API apps. And using those API apps, you can use logic apps to kind of do business process automation. So you can take data out of one thing, put it in there. For example, you could take all of your tweets in the last month, you could do sentiment analysis on them, and then you could put them in the Dropbox as a text file without writing any code, all by using logic apps and API apps. So these are the four kind of pillars of the Azure App Service. The one we're going to focus on specifically is the Web App Service. So the Web App Service, it's PaaS, Scalable Web Hosting System. So PaaS means Platform as a Service. So a lot of you will probably be familiar with that term, but just in case, you have two terms in cloud, well, three terms really, but two terms in cloud, PaaS and IaaS. So PaaS is Platform as a Service, IaaS is Infrastructure as a Service. IaaS is the idea of basically taking what would normally be on a server in your environment and moving it to a virtual server in the cloud. You still have to manage the server, you still have to manage the operating system, you still manage everything that goes on that. So you basically get given a virtual bit of hardware in the cloud and you manage that as you see fit. That's IaaS. PaaS takes away the concepts of servers. So you simply have a service or a platform and you upload your things to that, and it manages all of the server maintenance and backups and patching and all that kind of stuff for you. You don't care about that stuff in the PaaS world. And the web app service is a PaaS service for hosting web applications. It hosts any type of web application, so we're obviously quite interested in ASP.NET, but it hosts all the others as well: Java, PHP, Node, Python, etc., etc., etc. So it doesn't matter what you're writing your web application on, you'll be able to host it in the Azure Web App Service. And it's not just hosting; it has a load of stuff that is kind of value add, and we'll go through some of this stuff during the course of this talk. So let's first talk about deployment. Let's talk about this idea of getting something off your machine onto the cloud. So we've all done this, right? We've all done keep calm, it works on my machine. I've done this. I do this on almost a weekly basis, where I develop something, it works, and then you put it somewhere else and it doesn't. So the way you get around this is you deploy as frequently as possible and as early as possible. Get the stuff off your developer's machine into some kind of system, ideally the production system or production-like system, and try and go through this process of dev, test, stage, live. So try and have different environments that your application runs in, and move it through those environments as it progresses, so that you can check your deployment process and check that it works on other environments. We have a feature in the app service called continuous deployment, which really helps with this idea of continuously deploying your software. So it basically means you can deploy directly from source control. So as soon as you check in or commit or whatever it is you do on your source control system, it will deploy automatically to Azure without any intervention at all. So it supports Visual Studio Online, it supports GitHub, Git, Bitbucket, all of the main source control systems are supported with this. And of course, it doesn't just deploy, it gives you history, roll back, roll forward, all that kind of stuff. So the idea is that it's not really intended for production use, but certainly in a dev or test environment, you enable this, and as soon as you do a commit, it's deployed, and you can go to a live URL and you can test it and see if it works or not. Very useful feature. Another feature we have in the app service is called deployment slots. So this is an idea of basically having multiple versions of your live site. So you've got your main site, and then you've got another deployment site you can deploy to and test it out before you swap it over. So it's useful for stage deployment, so it's useful for going through these various deployment models. It's also useful for things like A/B testing or split testing, where you actually do want multiple versions of your live site, and you can redirect traffic between one and the other. And again, you can swap and roll back. So the idea is you have your production version, you have a beta version, you deploy to that, and then when you're ready to make that live version, you just do a swap, and Azure manages all that for you in the cloud. You don't need to worry about redirecting traffic or anything like that. It's all taken care of for you, and you can roll back if you need to as well. So very good feature, very useful. So let's take a look at some of these features now in Azure, and let's take a look at deploying a web application into Azure. So we'll start off in the Azure portal. This is the Azure portal. We can go to new, web and mobile. I'm going to create a new web app. I'm going to give it a name for the web application, so I'm going to call this MS Web Day Scale. So this is going to be a version of our MS Web Day website. It's just going to check that that's a URL. I'm going to put it on Martin Beebe's subscription, because that's a good place for all of my stuff to be. I'm going to keep the standard resource group. Resource group is a way of collating resources together, so you can manage them in a single place. And then we're going to create an app service plan. So this is the billing bucket for the whole or anything that I want to put on this. So this one service plan would support web apps, mobile apps, Azure apps, and API apps and Logic apps. And then I'm going to put it in North Europe, which is in Dublin. West Europe's in Amsterdam. Just take a minute to think about that. And we're going to set this off, and it's going to create. That takes a few minutes. So that's now been created. And we can go into the settings here, and we can see that we've got a URL. It's mswebdayscale.azurewebsites.net. And you can actually click on that, and you can go to that. And you'll see it's a blank website. So nothing's been deployed to this at the moment. It's just an empty sort of placeholder page that Azure gives you by default. So what I want to do now is I want to set up deployment to deploy from my GitHub. I've got a version of the site in GitHub, and I want to deploy that from using the continuous deployment. So I go to continuous deployment. I choose the source, which is going to be GitHub. You can see there's lots of others, and this is the repository. So you can see that I can pick the URL there. Although I don't need to, I can just select it using the interface here in Azure. It's already authenticated as me, which is great. I can choose my project or my repository in GitHub terminology. I'm going to choose the one out of the list here, MS Web Day Scale. There it is. You can even choose a branch if you want to. So I'm going to deploy straight from master, but you could have a deployment branch if you wanted to do it that way. So I'll click OK, and what's going to happen now is it's going to reach over to GitHub. It's going to grab the latest version of that repository, and it's going to do a build, and it's going to deploy that build to be my live site. So you can see it's doing the fetch from GitHub there. That takes a little while. This whole process takes a couple of minutes depending on the site. And it's going to do the build for us, and it's going to make that the live version of the site. Okay, so you can see that's done now. The latest check-in was called Open in VS 2015. And if I now go to my live site and do a refresh, we should see that I've now got an actual version of the website up and running there. And there we go. There's our site. It's been deployed. I haven't opened Visual Studio. I haven't written any code. I've just taken what's in GitHub and deployed it. So let's say that I want to make a change now. So we've got it set in Manchester. I live in Droitwich Spa, so I'm going to actually change this. It'd be quite handy for me for the next event to be in Droitwich Spa. So I'm going to change that to Droitwich Spa in Visual Studio. I'm going to do a save, and I'm going to do a check-in. So we're actually using a commit. Sorry, we're using GitHub here, but it would be the same if you were using Visual Studio Online or any of the others. And they call this commit change to Droitwich Spa. I'm going to do a commit, and then I'm going to sync it up to the GitHub servers. There we go, syncing, pulling the current branch, and there we go, that's now synced. If we go over to GitHub, we'll see that that repository, that commit has been landed there. So we can see we've now got 4 commits. The last one is called change to Droitwich Spa 21 seconds ago. And we don't need to do anything in Azure. It will just deploy this automatically for us. There we go. It's automatically picked it up. It uses webhooks behind the scenes to run all of this. So GitHub has a webhook into Azure. It's deployed it. It's changed to Droitwich Spa. And now if we refresh the site, we should see that change that I made has been put into place there. And it's set to Droitwich Spa there. Excellent. So we've deployed from Visual Studio. We've checked into GitHub, and it's deployed automatically out to Azure. Now let's say I want to redeploy that, because obviously we're not going to go to Droitwich Spa. It's a tiny little place. Manchester's a much better place for us to go to. So I'm going to redeploy the old version of the site now. I just go to it, I click redeploy, and then in a few minutes time, it just re-gets that version of the site, rebuilds it and redeploys it, and now that's going to be set back to Manchester, which is all very good. So that's continuous deployment from GitHub. Like I say, it works exactly the same way from all of the other source code repositories. Next thing I want to do is look at deployment slots. So I want to create a beta version of the site and deploy to that and see how that works. So I'm going to go into the site. I'm going to go down to deployment slots. And I'm going to create add slot. I'm going to give this the name of beta. And I'm going to choose to clone the existing configuration. So this is basically going to take the current setup, clone it under the name of beta, and it's going to give it the URL of mswebdayscale-beta. And that's basically it's like a separate web application, but it's mirrored the one that's already here. So if we go into this, it's going to have all the same settings, all the same configuration options. It's going to have the slightly different URL. And of course, this is blank at the moment because we've only just created it. So we haven't deployed anything to this yet. And the old URL is still there as well. So let's look at deploying this. So I'm going to go back into Visual Studio and I'm going to do something like, I'm going to change the background color of the register button. I'm going to make it a bright pink to see if that has any difference in people registering or not. And then I'm going to get what's called a publishing profile. So a publishing profile is a thing that you can import into Visual Studio to actually help publish the thing directly from Visual Studio. So if I go to publish, I go to profile, I can import. You can actually do it directly from Visual Studio as well. You don't need to download it. You can just go to Microsoft Azure Web Apps and do it that way. It's got all the passwords and all the details in there to be able to deploy. So what I can do now is I can click publish. And then after a little while, that's going to have been published, and we can refresh that and see we've got this version of the site with the pink button. There we go, we've got the pink register button on the beta version, and we've got the grey button on the live standard version. So two versions of the website sitting side by side now. So let's say we want to swap that. We want to put the beta version as being the main the site that's live on the main URL. So we just go to it, you go to swap, you choose the source and destination. You can have up to 10 of these deployment slots in the standard setup. And it's swapping that across now. So no traffic will get lost during this. It will keep the old version up there until the new version's ready. And now it's swapped and done. So if we go to the main URL now and do a refresh, we should see a pink button. And there it is. And if we go back to the beta URL, that's got the old version of the site on now, and it should be a grey button. And the idea is that you would then deploy your very latest version of the site to that and continue across this path. So we've deployed to the beta swap there. We've swapped it around, and that's all working very nicely. So then we're going to talk about scale. So this idea that your site is a living thing that needs to grow and adapt. Over time, the load on your site is going to change, and you need to make sure that your site adapts to those changes in a smooth way without any interruption. So you may recall Black Friday last year and the year before. A lot of the websites, a lot of the big UK retail websites were down for proportions of that day. In Black Friday 2014, there was one particular retailer who were down. They were down the whole day, so nobody could buy anything through their website the whole day, and that's because their site wasn't set up to adapt to the load that was going to come now. Obviously, that's an extraordinary circumstance. It's one of the biggest online shopping days ever, but even so, there are ways that their sites can adapt. Amazon was up the whole day, and they were able to service customers the whole day long. So having a site that scales is very important. And the way you start this is by understanding your load profiles. So there are four main load profiles: batch, predictable, increasing, and unpredictable. Batch is really where our site that we use for this event is very typical of a batch load profile, where today there's going to get a lot of traffic because everyone's going to be using the site, but tomorrow we haven't got an event, so nobody's going to be on that. So it goes on and off. And that's also predictable. So predictable is where you know when you're going to get a lot of traffic. So for example, the Euros are on right now. People, when there's a football match on, BBC know they're going to be streaming that football match on their website, and they know they're going to get a lot of traffic. So they can predict that. If you're in e-commerce, 8 o'clock on Sunday evening is the peak time for e-commerce on eBay. So eBay know that, and they can scale their servers appropriately. You're also looking at potentially increasing load over time, which is where it generally increases over time. But in reality, most places are kind of unpredictable. We don't really know when we're going to get load and what the impact of that's going to be. But it's important to understand your load profiles in architecting your Azure to match it. So there are two ways to scale your servers, always has been. Scale up, which is make your servers bigger. So add more resources to the existing servers, more memory, more disk, more CPU. And scale out, which is add more servers that do the same thing. These are two main models, and we can represent both of these in Azure as well. So in terms of scale up, Azure has 5 server sizes. So though it's a PaaS system, we still use the concept of server sizes to kind of monetize how big of a resource you're getting. So we have 5 different server sizes that you can use, and those go across 5 different pricing tiers as well. So each tier has different features that open up and different levels of capacity. So you go from shared, free, basic, standard, and premium, the 5 tiers, and each one of those standard has S1, S2, and S3 for the different server sizes in there. So that's useful, and that's how we scale up inside Azure. We can also scale out using a feature called auto scale. So this is this idea of scaling out by adding more servers based on CPU or a schedule. So what's great about this is it'll scale up and down automatically. So you can set it you can set a range that you want your CPU to be at, or other performance metrics. And if it exceeds that range for a period of time, it will automatically add another instance of another server to your application. to satisfy the demand. The best thing about this is it will also remove that server when the demand disappears as well. So you only pay for what you need here. You can scale it, I think it goes up to 10 instances. You can scale up to 10 and then go right back down to 1 when you don't need it. So the great thing is here is you don't need to worry about your load profiles. Just set this up and you know that Azure is going to take care of it for you. You don't need to worry about, is your server going to scale properly with all this traffic? And so let's take a look at how we set that up using the Azure portal. So we'll go back into the portal and we'll start with the same web app we did before, the MS Web Day Scale web app. And we're going to set up auto scale here. So at the moment, this is running on a single instance using the standard small, so S1 server size. It's running a single instance here and it's set to manual scale. So I can manually add instances if I want to, but I'm going to set up auto scale, which is where I say scale by CPU. So I can set a range of how many instances I can add. I'm going to allow this to add up to 10. And then I want the target range for my CPU. So I'm going to set a deliberately constrained range here because I want to be able to prove that this auto scales. But typically you'd have kind of maybe up to 80% CPU as being the target. So I'm going to set 15 to 25 here as my target range. I'm going to save that, and that's now set up for auto scale. So if my server goes over 25% CPU for a period of time, it will automatically scale up and add another version of the server. So now I'm going to set up a web test using Visual Studio. So this is a feature you get in the professional version of Visual Studio. I'm going to set up a web performance and load test report. I'm going to just save that to my local folder here, demo dump. I don't need to put this in source control, thank you. And what this does is it lets me set up a URL that I want my test to access. So in this case, it's just going to be the standard URL. And I do this by doing an add a request, set the URL to be my main Azure URL, which is mswebdayscale.azurewebsites.net. The next thing I need to do is add a loop. So I loop around this URL a number of times on the tester. So I'm going to set up a for loop. I'm going to give it a name. So I'm just going to call this iterator. I'm going to set the terminating value to be 1,000. And then the increment value to be 1. So this is going to iterate. Basically, it's going to iterate through that test 1,000 times. And I set the tests that I want to use. You can choose different tests if you want to. If you have a number of different tests for different URLs and parts of the site. So that's the web test. That's going to iterate 1,000 times. I now need to set up what's called a load test, which is where I execute that web test with a number of users, a number of fake users. So I can simulate think times. I can choose things like how many users I want to use. So I'm going to set this up to be 300 users. I can choose how I want the test to execute. I've only got one, so sequential's fine, but you could have multiple tests here and have those execute in different orders. I can simulate different network conditions, different browsers. I can choose where and how this runs, and I can choose the duration as well. So I'm going to actually run this for 5 minutes. So I'm going to run it out of the Azure data center, my default one, which is Dublin in my case. So click finish, and now I can right click and run tests. And this is going to it's basically simulating 300 users hitting the website 1,000 times each over a period of 5 minutes. So it should be enough to generate a decent amount of traffic there and hit those thresholds in order for Azure to auto scale. So as you're running the test, you get this kind of report in Visual Studio. You can see how it's going, and then when it's done, it looks a little bit like this. You can see that how it's executed and what happened during the course of the test. So if we go back into Azure, you can see there's all the traffic that's come in there, and we can see it has indeed scaled up to 2 instances. So it's auto scaled only to 2 in order to satisfy all that traffic, which is great. It meant that the site remained responsive during the period of the test. Now, after a few minutes time, it's actually going to scale that back down to 1 because the load's now gone away. But that's auto scaling actions. Very good feature. So next, let's talk about storage. So storage is an interesting one. So a lot of people would deploy their web application. They'll put all of their static files in the web application, which is served from their web server. There's a few problems with that. Basically, you're better off serving files from a CDN like Azure Storage. It's quicker, a lot quicker, which we'll show in a second. It's a lot cheaper and it's a lot easier to work with. So rather than having static files like your images, your CSS, your JavaScript, your font files, don't put those on your web server. Put those in something like Azure Storage instead. And also it lets you attach a CDN, which basically brings the data closer to the users. So let's have a quick look at using Azure Storage and some of the differences that makes in terms of performance. So we'll take the same website again. I'm going to run this and we're going to look at the sort of logo at the center of the page and just see that that's running at the moment from index files, which is part of my web server. So this logo here, this Microsoft Web Platform logo, if we just run F12 in Edge or any browser, we can go and inspect that. There it is, and we can see that it is indeed being served out of index_files, which is local to my web server, and it's called titlewebplatform.jpg. So what I'm going to do now is I'm going to create an Azure Storage account and serve that file from there instead and see what difference that makes. So I go back into the portal, I go to Storage Accounts, I can do Add, I can give this a name, so I'm going to call this MS Web Day Scale. You can choose things like what type of redundancy you want, so whether you want it locally redundant or geographically redundant, there's costs associated with all of that. I'm going to just accept the defaults in this case. I can choose a resource group. I'm just going to create a new resource group for this. Actually, I'm going to choose the MS Web Day one, and again I can choose a location. So click Create. So that's my storage account created. So storage accounts do lots of different things. They can store table data, files and various other things. And they also has this thing called a blob service, which is binary data. So basically files, CSS, JavaScript, that kind of thing. Now, blob service works with this idea of having containers, which is kind of like a top level folder. So I'm going to create a container here called static. I'm going to set the access type for that container to blob, which means it's available as via anonymous requests, which is what you want for this kind of data. So that's now created, and I need to somehow upload some files to that now. And one of the easy, there's lots of ways to do this. There's lots of tools available, but the tool I like to use is called Cloud Explorer, which is a part of Visual Studio. And you get this through the Azure SDK. So you can just search for Cloud Explorer there if you can't find it. And if you've got the Azure SDK installed, it'll be there. And what this lets you do is this lets you basically explore your entire Azure subscription. So all the things you've got in Azure, you can explore those and do interesting things with them. So I'm going to go down to the storage accounts. There's my MS Web Day Scale one. There's the blob containers, and there's the static blob container that I just created. Now I'm going to open this up in the blob container editor, which is kind of like an FTP client. It lets you interact with the files on there. There's nothing in there at the moment, so let's upload that image to my blob container and see what happens next. So choose titlewebplatform.jpg, that's the same image. I'm just going to upload that. Now everything in the blob container has a unique URL. So this now has a URL. I won't read that out, but you can see that that's got a full URL. So I'm going to copy that URL. There's the image, just to prove it's exactly the same image. Copy the URL. And I'm now going to set that in my web page to use that URL rather than the local version of the image. So let's reload the website and see what difference that makes. What we're going to do is we're going to look at the speed difference in the way that's served. So first you'll see the website's exactly the same. The image gets rendered in exactly the same way, no problem at all there. We can inspect the element just to prove that it is being served from storage rather than from the web server. There it is. There's the full URL there just to prove that. What I'm going to do now is set up a network trace to look at the performance benefit of doing this. So I've done started network trace now, reload the page, and let's have a look at this. So this image is the biggest one on the page, and the yellow bars indicate how long they took to load. So notice that although it's the biggest image, it took the shortest amount of time to load. It loaded in 55 milliseconds compared to the 902 for the image below it. So it's significantly faster to load from storage than it is for loading from the server. So 55 milliseconds for this image compared to 902 for the smaller one that's below it. and 222 for the other smaller one that's above it. So much faster to serve images and static content from storage. I also have the benefit of being able to attach a CDN to that as well. So covered a lot there. We've covered deployment. So we looked at deployment through various ways, through the publishing profile, through continuous deployment from source control. We've looked at scaling using the auto scale and the web test loads there to push the servers up and then scale back down when the loads disappeared. And finally, we've looked at using Azure storage to serve images and static files much cheaper and much more efficiently. I've been Martin Kern. You can contact me, you can tweet me, you go to my website, martinkern.me, where all the resources are there. And if you've got any comments or questions, you can just email me. Thank you very much.